Welcome. Introduction to Inferential Statistics by Articosa. We consider a population whereby we're going to take a sample, then we'll use that sample to represent the entire population. The reason being, it's not easy to calculate every element in the population. For example, here in Earth, suppose I was to calculate the number of people on Earth. Since every day some people die and some people are born, I can't just get exact number, but I can estimate. It's just to count those people whom all have the IDs. Then I say the world has this number of people, but there will be some people without IDs, so which they're not yet registered, so I can't. So it actually census collecting all population, and it's very much expensive. It takes time. So, but for us, the advantage of taking a sample is very much cheap and affordable, and it also saves time. So, our focus is on the data collection. So, all elements of the population. So, data collection is defined as a systematic approach to gathering and measuring information from a variety of sources to get a complete and accurate picture of an area of interest. So you have the primary data. You can collect the data originally by yourself, or the secondary data, you can use the data that is already collected by someone. So you can just take a sample from the population, where a sample is just the portion of the population available for analysis. And under data analysis, here we practice or to work with data. So we're gathering this data bit by bit, useful data, and we'll use this data to make informed decisions. So which is an inference. So population, as I said, is just the entire collection of elements, a group of people or things. So under inference, we have confidence interval and hypothesis testing. So for confidence interval is a range which is defined by a specific probability that a value of a parameter lies within it. So hypothesis testing allows us to make probabilistic statement about the population. We have statistics as the numerical information about a sample, and parameter as the numerical information about the population. In other words, sampling is a method that allows researchers to make decisions about a population based on the results taken from the sample. Here we define it as a process of selecting number of elements from the population to be studied. So also know that when we are collecting data, we may experience an error. So the error during the collection of data is called non-sampling error. So we also have sampling error, which we define it as the deviation between the sample statistic and the true population parameter. So our sample statistics are just our point estimate, which are estimator functions from the sample that are used to estimate the population parameters. So we have the sample size, small n. We'll use it to estimate the population size, capital letter N. We have the sample mean, x bar. We use it to estimate the population mean, mu. We have the sample variance, S squared. We'll use it to estimate the population variance, sigma squared. We have the sample standard deviation, S. We'll use it to estimate the population standard deviation. We also have the sample proportion, P hat. We use it to estimate the population proportion. So sampling error is just the difference between the sample statistic and the population parameter. So these are the results. We also have methods of sampling. probability sampling and non-probability sampling. Let's discuss each of them. Probability sampling. Sampling based on the fact that every element of a population has a known and equal chance of being chosen or selected. So here we consider a finite population, a population with finite number of elements. So we'll indicate the number of elements as capital letter N, which is just the size of the population. We also have infinite population, which is defined by infinite number of elements, which can be defined within intervals. So under probability sampling, we have simple random sampling, systematic random sampling, stratified random sampling, and cluster random sampling. So we'll start with simple random sampling. Sampling where every sample of size N in the population of size capital letter N has an equal chance of being selected. Don't forget the small n is just the sample size and the big N is just the population size. So under simple random sampling, we are going to be sampling with replacement and sampling without replacement. So we have the number of samples for sampling with replacement and sampling without replacement. So the number of samples for sampling with replacement is given by the population size to the power sample size. And for sampling without replacement is given by the population size combination the sample size, which can also be written as the population size factorial all divided by the sample size factorial open bracket the population size minus the sample size all factorial. So for example, let's take we're having a population of 4 and a sample size of 2. So to find the number of samples for with replacement, we'll say 4 to the power 2. So we'll have 60 number of samples. Without replacement, we'll say 4 combination 2. We'll have 6 number of samples. Secondly, we have systematic sampling. So for systematic sampling, the first element is selected randomly from a list sequential files, and every kth element is selected where our k will represent our interval. It will be given by the population size divided by the sample size. So the random start we can start anywhere, but we'll select the next element depending on the interval. An example, suppose we're having a population of 200. We want to select a sample size of 20 individuals. So our interval will be 10 since it will be given by 200 over 20. So we're going to start at any point, but on the first 10 individual. It means as long as we're starting within the interval of 10. So I can start, if I start at 2, it means I will select every 10th individual starting from 2. So I will select 2, 12, 22, 32, 42, 52 until I select my 20 individual, which will be 192. So systematic sampling is a sampling that selection is done randomly at an interval. So now let's move to stratified sampling. Under stratified random sampling, population is divided into homogeneous groups called strata, and elements are selected randomly from each stratum. So to indicate this clearly by an example, suppose you are given a population with a size of 180 and you are to select a sample size of 60, given that the population size for stratum 1 is 30, for stratum 2 is 60, and for stratum 3 is 90. Then you'll have to find the sample size for each stratum. So this is how you do it. The sample size for each stratum is given by the population size in each stratum divided by the overall population multiplied by the sample size. So which means for stratum 1, it's N1 is given by the population size for stratum 1 divided by the overall population times N. So it's 30 divided by 180 times 60, you'll get 10. So which means 10 individuals will be from stratum 1. For stratum 2, the sample size is the population size from stratum 2 over the overall population size times the sample size is 60 over 180 times 60. You'll get 20 individuals from stratum 2. Similarly, from stratum 3 is given by the population size from stratum 3 over the overall population size times the sample size, which is 90 over 180 times 60. You will get 30 individuals from stratum 3. So if you add 30 plus 20 plus 10, it will give you 60. So that's how stratified random sampling works. Lastly, on probability sampling, cluster random sampling. So population is divided into clusters and elements are randomly selected from a chosen cluster. So unlike stratified, where we'll have to select randomly from each stratum, here we just select on a chosen cluster. So if we choose cluster 1, it means we're going to select elements randomly from cluster 1. That's all. Under probability sampling, non-probability sampling. For non-probability sampling, this one, it involves selection of individual based on non-random criteria. Not every individual has a chance to be included in a study. We also have 4 types of non-probability sampling, which is convenience sampling. Convenience sampling, it involves on the selection based on convenience. So an example, people interview on street, class of student, co-workers, churchmates. We also have a snowball sampling. So it's also known as the network sampling. It begins by identifying someone who meets the criteria for inclusion in the study. The particular person is asked to recommend others who they know and who also meet the criteria. That's snowball sampling. And we also have quota sampling under non-probability sampling, which this one, it involves selection based on subjectivity. This is what people used to do before in 1948. Sampling here is based upon quotas. So more than one strata, quotas are just grouped more than one strata. For instance, each interviewer will sample based upon quotas that are representative of the population, where the selection of the respondent is left up to subjective judgment of their interviewers. The bad thing is the selection of respondent is in the hands of interviewers. How can you ensure that the sample of the students that you have selected is indeed representative? If you are subjective when it comes to the individuals sampled, then this is an example of quota sampling. Hopefully you understand quota sampling when I say selection based on subjectivity as an example of quota sampling. So lastly, under non-probability sampling, purposive or judgmental sampling. So this one involves selecting of sample based on judgment, sampling with a purpose. So this one, it is based on someone's experience. So the disadvantages of non-probability sampling is biased. Biased means it's a favoring of certain outcome over others. And another thing is that sample is not representative. So that's all I have for you on this session. Thank you. Please keep on subscribing, and I advise you to look more on this probability sampling and non-probability sampling, the advantages of each sampling method. Thank you. You're all welcome.